So my name is Rahul Kumar, and I'm a senior applied science manager at AWS. I lead a team that works on Rust verification, C code verification, and we are very, very passionate about bringing formal methods into the mainstream, especially for Rust, which is what this work is about and what I'm going to talk about a bit more. Previously, I worked at Microsoft Research. I worked on C code verification and a little bit of empirical software engineering techniques. And then before that, I also worked on the Europa Clipper mission at NASA JPL. So very exciting.
Yeah. The first question to ask, I suppose, is what is formal verification? But can I actually intercept myself by asking something else, which is I thought Rust was a safe programming language. And you made a special note to say that you are especially interested in verifying Rust. And so can you describe to me what how Rust is sort of is Rust lying to us? Like what are the holes that need to be filled?
Yeah. So very first, I'm going to say, no, there's no lies here, right? That would be a bit aggressive. Rust is an amazing programming language which provides fantastic compile time guarantees that most other languages will not provide you. Rust does have an escape path to perform certain functions. And that's called the unsafe part of Rust. It provides you so-called superpowers to achieve what you're looking to do. And there are various reasons why one may choose to adopt those. So number one, no lies. Number two, yes, we have an escape path. And at that point, the compiler will stop giving you guarantees that it traditionally would in safe Rust. Now, what does that mean? That basically means that the compiler is expecting some sort of human assist or potentially AI assist in the future to enable you to give the guarantees for yourself.
So I would normally describe this as the burden of proof kind of shifts from the compiler to you as the programmer. How does that sentence fit with you?
That's a wonderful way to say it. And you use an interesting word in there called proof. Right? Because the compiler is actually in the safe world giving you proofs that you're okay. But in the unsafe world, it is not giving you that proof. So while you may run this particular piece of code 1,000,000 times and never have an issue, you don't have a guarantee, which is what the proof will give you at the end. And yes, the burden of proof is on the programmer.
Right. I need to kind of, I did an undergraduate degree in philosophy actually. And just kind of this is sort of bringing up old neurons are activated about inductive and versus deductive logic. And the fact that essentially it doesn't matter how many times it's right. If you can't guarantee that it might never be wrong, you still never have that kind of quality and
the assurance, if you will.
Sure. Yeah. No, absolutely. So just because there are a couple of people who are terrified of this keyword unsafe, but so I think one of the other things to possibly explain is why we might use this escape hatch. And sometimes it's impossible to avoid, such as if I want to talk to the operating system or I need to talk to some other library that might be written in a different programming language. And it's impossible for the Rust compiler to make some sort of assertion or guarantee about programs that live somewhere else. That's one case where it might be impossible to avoid unsafe.
Yeah. you wanna use some foreign language interface, or you wanna dereference raw pointers, the so-called 5 superpowers that Rust has. In all of those cases, either you are functionally bound and you want to achieve a particular function at the end, or a functionality at the end, which you're not able to do because of safe Rust. Great. That's a perfectly valid reason to do this. Or maybe there is a performance concern because safe Rust could potentially introduce checks that you are not very interested in having, and it causes a performance slowdown. Again, coming back to the...
At this point, it's this temptation of, well, I could go faster. Like, essentially, I know that like in sort of scare quotes there, because I might be wrong. Like, it turns out that humans are often wrong about these things. But, for as far as I can see as the programmer, I am upholding invariance around memory safety and so forth. And so I could essentially skip safety checks that the compiler would otherwise kind of inject. And and suddenly I'd get like let's say, I don't know, a 2 or 3% speed up in code that might be, okay, interesting.
Yeah. So imagine developer X tasked by their manager to take a piece of C code, and manager says, I want you to go make this in Rust because I've heard it's safe and faster. And developer X goes and rewrites it in Rust and safe Rust, and turns out it's actually the same performance as the C code because there's a bunch of safety injections in there. And then they experiment and go into unsafe mode, and turns out it's actually a lot faster. But now we don't have a proof of correctness, which the safe Rust would have provided. And at that point, yes, the burden of proof is on the developer. And that's a simple motivational example. This has happened in real life. We have seen examples of this. Unsafe Rust tends to have a very, very useful function, and we support it. The place that we are coming from is, look, even if it's unsafe, why don't we go provide you those assurances that would not have been possible before? And that's amazing because now you can probably go into unsafe and achieve the functions that you want to achieve and still have guarantees for the future.
So, and this is verification. So I expect that the term formal verification has a very precise technical meaning. Do you want to, is that correct? And if so,
yes,
do you want to
we want to use we want to use mathematical logic to prove properties about your programs. And formal verification, in a sense, you could say, well, I want to go verify a model of something. That's fine as well. But the artifact that you are dealing with, which you are most interested in, will exhibit certain properties, and we want to go prove properties about that artifact. And we want to prove them exclusively, unboundedly, in permanence, if you will.
And I suppose one of the things that was fascinating to me about one of the tools that hopefully we'll get to chat about, called Kani, was that it's all symbolic. The actual code itself doesn't really get executed. It kind of as far as I can tell, gets translated and then run through an SAT solver, and then so it's almost as though you're operating with software, not as a set of instructions for a computer to kind of go from top to bottom through, like you might think of it scanning through assembly, but as a series of like symbolic instructions, much more at a sort of a higher level, and just the structure of the way that the program is operating allows the solver, or allows the tooling, to make some sort of inference, or actually deduction about correctness.
Yeah, I think the word which would be appropriate here is semantics.
Mm-hmm.
So semantics and then specification, right? So we take the input and we process it according to the semantics that are defined. And interestingly enough, there are situations with programming languages where semantics are undefined.
Right.
And that's something that we would like to also change. So attacking this core problem of, let's go verify the Rust standard library. Let's go verify the core library. Well, we're now in a place where we're challenging a community to actually formally define the semantics, right? There's this funny.
So if hopefully an example will pop into your head just immediately, but if essentially there's a gap in the specification where it kind of provides wiggle room, which makes it essentially impossible to verify because there's ambiguity there. Is that the problem?
Yes. And a funny party trick, right? That used to be played in the math clubs was, oh, let me prove 1 equals 0. And the essential idea was that you're dividing by x minus x, right? And you can go prove 1 equals 0 to somebody who doesn't realize that this particular semantics is prohibited. It's not allowed. And with Rust or with a lot of programming languages, in fact, maybe all, I'm not sure. It is true that there are gaps in the defined semantics, and we would like to close out on that.
So formal verification would I associate, or at least I have been associating with things like TLA plus, or there are a couple of other modeling languages. Some are easier to use than others, but typically they are difficult and very complex and challenging. Do you have any thoughts on why why formal verification is so difficult for, let's say, most programmers, and that it seems like a very specialized topic? But
so I will give you that it is specialized. Number one. Number two, I think that the examples you cite are also interesting because they're not directly processing what a software engineer would go write and deploy at the end of the day.
Yeah, they're modeling.
Right?
Well, at least LA Plus is definitely
And then you have program verification, program analysis, and tools like Connie or Veris would fit into that domain where we're actually trying to operate on the code that is being deployed. And one of the goals for us is to make this as automated as possible. So yes, would we like you to specify properties? Absolutely. Right? Because that's something that you know about. You know your code. But do we want you to go create models? Probably not. We're trying to do that for you. And we can do that for you.
And so it sounds like one of the barriers has been, well, you need to, if you want to learn formal verification, or at least some subset of the domain, then you need to go learn a modeling language and create a specification. Whereas, let's say, newer tools, or the Kani in particular, essentially, it's just Rust code, and it's actually embedded in the code that you're actually running. It's not some separate artifact. And so, I personally, when I've used Kani, have really appreciated that essentially the tooling kind of comes to me, and that I don't need to go out to something else and use a different workflow. I can just use Cargo, for example, to drive it. I think, the
ergonomics of making this real and scalable are so important. And, imagine being in a meeting where you go from discussing highly symbolic execution-oriented algorithms and problems with them to, well, we think this should not start with a star. It should be an ampersand. And both are amazingly valid, because if you want to push formal verification to the next frontier, make it part of the main line, this is what it takes. You have to work on both ends of the spectrum.
Mm-hmm.
You can go make the best engine in the world, but if you don't have a beautiful car on top of it, people aren't really going to drive it.
Sure. Yeah, I spend a lot of time picking at syntax as well, even though it feels in some sense meaningless or trivial or somehow less important, but really nice syntax kind of lends itself to really nice programs in a way. And so the struggle is kind of real, I think, when you're designing a language about, like, do we use curly braces? Do we use angle braces? Something I don't know. But the idea here is that we have a tool, Kani in this case, which can take Rust code, reason about it symbolically, and essentially make some sort of guarantee, or that the properties of correctness are maintained through the use of unsafe. Surely the project is not yet done. Are there kind of known limitations? Where, I mean, presumably there are. You know where the gaps are, I hope.
Right. So I have 2 or 3 things to say here.
Sure.
So number one, yes, we do have limitations, and we publish them, and believe me, we are absolutely 100% on the ball about making sure we publish these, because no false guarantee should be made. Right. Number 2, there's a distinction between these generic properties versus user-oriented properties. And right. And you can make, you can go check for certain UBs which come right out of the box with Kani, because hey, that just applies to everything in Rust, right? But then if you want to go say, I'm very highly interested that this particular variable never exceeds the value of 42. Okay, you can go write that property and prove it. And there's a fascinating example. There's a repository out there called Hi-Fi Time, and there's a blog post on the Kani blog about proving the correctness of Hi-Fi Time. It's a time library for the solar system, if you will, operating across multiple time zones. And Christopher Rabbiton, who wrote the blog post with us, or mostly by himself, but we reviewed it, which was nice. One of the first external contributions to the Kani blog, picked up on Kani and used it to prove correctness of so many functions for the next 36,000 years.
Incredible.
Right. And those are such custom properties that he's working with, right? Amazing stuff. AWS Firecracker, which is a VMM that is open source on GitHub, and we rely on that quite a bit. They have so many custom properties that they prove about their code base and how they deal with certain issues. Those are fascinating, user-oriented functional properties that people are proving. In addition to the generic UBs that they don't want.
So can I, just as a hypothetical, I'm not sure, like I literally don't know if this is possible. It would be wonderful to have let's say a percentage type, which is encoded as floating point, although maybe it should be irrational using an integer, but let's say it's not. And so I'm using floating, and I want to guarantee that the use of my percentage is always between 0 and 1. So essentially, it's bounded inside those. Is that something that I can ask Kani to check so that I should never be able to have
out of the box?
Okay,
but you can by encoding a custom property. Yes,
nice.
Which we give you the ability to.
Yeah, I've always kind of been in. There's a part of Ada which I have always been fascinated by, whereby you can have types which are constrained by their ranges rather than having all integers available to you. You've just got some subset, and I've always wondered how that is implemented, because the representation in memory is presumably just an integer, or for example. And
well, so you bring up specifically floating points, which I think we have a bug on, but I'm not sure. Let me be clear about that. And we claim that in our list, but
floating point is much harder than integers, which is kind of why I brought it up.
That's kind of where I was going, right? So if you're sticking to integers, yes, you can restrict it. Floating points, I believe we're trying to. There's certain SIMD instructions where we have like a small issue. Modulo becomes interesting,
a bit
incomplete. So, yeah.
Look, I think the fact that these are the goals that you're striving for, and I know, I mean, it's sort of incredible, and I wonder how that would translate through unsafe. Like you've mentioned UBs are like a general class of problems that we wish to avoid. So we want to remove the possibility of undefined behavior. I suppose this would be classified at build time or at test time. And one question mark that that's kind of lingering around is how Kani differs from other tools in its space that are achieving similar things, such as like the Miri. Is an interpreter. So this operates in its model of operation is much different.
Yes. This is a great question. So, there's a spectrum of tools, and each and every single tool comes with its benefits, right? You can start with basic dynamic execution. You can go to testing, you can go to plus testing, you can go into model checking, which is where Kani fits, right? Then you go into deductive logic-based tools and higher order logic-based tools. This spectrum is very important, because the effort that we have, coming back to the Rust standard library verification effort, it's not about Kani.
Sure.
It's about ensuring that we can use this spectrum of tools to go give guarantees for the future. An effort, like at a very basic level, an effort is a collection of people who are trying to achieve a goal. And one of the first things they do is create a demonstration that, hey, I can go do something. And what we have done thus far is given a demonstration. And the idea is that more and more people join this effort and bring in their specialties and their tools.
That's extremely exciting. Do you think that although I'm just going to wait for my dog to decide to stop barking.
Sure.
I think someone just came home, which makes us excited. Here's a question for you. Do you think there are a large number of tools that are sitting in the darkness waiting to kind of be revealed to the world?
I don't know if sitting in the darkness is a phrase I would use,
Sorry,
but there are a lot of tools that can be used. Yeah. Look at tools like Crusoe, Aeneas as a great example. I think that's a wonderful tool. We are borrowing concepts from Aeneas. Varus is a great example. Kani, of course, since we happen to be closely related to Kani, That's how we wanted to make the demonstration and jumpstart. That's it.
So let's talk about this kind of project. We started chatting before on LinkedIn because I posted a note about something that I read that came as a joint effort from the Rust Foundation and AWS, and your name was attached, at least on the AWS side. So, what is it that you're trying to do?
Very simply put, we want to deliver the new era of programming language. So, we live in a world where AI has already proven to be very useful for certain aspects. I don't know how much you use it per se, but there's people summarizing things, there's people rewriting things, there's people now starting to make 20-second videos, images.
Look, I actually am increasingly surprised at how effective it is at getting me. I think when ChatGPT first came out, it was like really good at getting me like a first draft for some sort of piece of content that I wanted to produce. And now the models and also the tooling around the models and some and the increasing capabilities around RAG, which is I can't actually remember what it expands out to, but the ability that you could actually teach models about your own content means that it's getting better and better at source code and relatively complex. The context windows are increasing. So I would say I am one of the people that have high expectations for AI and its ability to remove a lot of tedium from the process of programming and a lot of mistakes. I think that it is, but I'm also relatively skeptical. Like, I'd rather be late and allow other people to feel the pain.
Yeah, absolutely. And I'm going to tie AI back to a previous comment or discussion actually that we had. You can go test something a million times, and just because it doesn't fail doesn't mean it won't fail. And AI, we all know we've actually experienced the hallucinations to some degree where you're like, well, that's not exactly what I was looking for. Now, AI is also beneficial in accelerating us at unprecedented levels.
Yeah.
When it comes to development of products and services and code, do I not want that? Of course I want that. But do I want appropriate guardrails around it, which help me develop confidence that, yes, I know that this AI gave me the right thing. And that's where formal verification comes in. That's where this effort comes in, because formal verification is the answer for producing those guardrails.
Right. So, okay. So now you have told a model, please generate a piece of code or, like fix this feature or fix this bug and whatever.
Yeah.
But you also but it kind of gets constrained by the fact that the tests must pass. And by the way, the tests are not just tests anymore. They're formal verifications of correctness.
Yeah. And that's a very strong statement because, let's say you want to go update your library and it has dependencies. The AI says, sure, no problem. Here you go. Here's a bunch of tokens. I'm just going to go spit them at you.
Yeah, right. I love tokens. Here's 1,000.
And then here's Rahul sitting on his computer going, should I commit this? Should I approve this pull request? I'm not sure what's going to happen here. But then the formal verification tool kicks in and says, hey, guess what? We just proved that this is great. It works. It's equivalent to what you had before. Go for it.
Yeah, and now essentially, well, yeah, that's just a huge new paradigm of writing software that you kind of have like this human augmentation. And I think that will be immensely powerful, particularly at big places where you have lots of hulky projects that there's never enough. It's really, I know that people say that we have these $1 trillion companies, but being someone who's worked inside one of them, no one ever has budget for like massive rewrites. And so I think this will liberate a lot of people. And yeah, one of the things I really appreciate about Rust is that you can feel is the notion of this fearless concurrency. That was pretty much the first slogan that people really understood when Rust first came out, like 2012, 2013. Fearless concurrency was one, and the other one would be blazing fast. Like those were the two things that really stuck. And now it sounds like what you're saying is the future. If we get it right, like it is literally a future that is not, there's lots of things that might go wrong, but in principle, the tooling should get sufficient such that that feeling of being fearless, essentially knowing that you can't crash, your programs will just carry on because they'll be correct. You actually know that. Like that would be an immensely liberating feeling for people that are building, which is amazing.
Yes, and I'll take it back a few decades, which some people may or may not relate to, but the amount of times we had to reboot a computer, and the wastage that produced. Well, imagine if you never have to deal with that again.
Is almost, but yeah, no. And there are some very strange things. I mean, if people who didn't grow up or didn't experience the dial-up era of the internet will never really. Once upon a time, you needed to literally plug the modem into the wall, like unplug the phone. Because you could either have a phone or the computer would be talking on the internet. And you'd
have your mom get a second line.
Right. and things like email it felt different because you on Outlook or like Thunderbird or whatever, there was a button like send and receive, because literally you need to phone in and download things from messages that come in from the server and re-upload. Now we think of email as essentially instant messaging. We're always connected. The protocol actually expects that everything is asynchronous and so forth. It still operates in an era where the whole everything is disconnected and flaky, but messaging is different. The internet feels different. It's essentially
and imagine the future computer scientist, which uses AI but guarantees the work with formal verification. Like, you and I probably sat down in IDEs and wrote code and debugged code. That's going to be an extinct, antiquated activity. It's like at some point people are going to be like, Grandpa, so you used to have an IDE?
Yeah. Well, I think of this like and it's interesting. I'm just kind of thinking about my own response to your comment. My immediate was like, it's kind of this, this kind of back, and it's like, no way, Rahul, this is nonsense. And then it's like, what? Pause. I think the same way about financial transactions in America. So in the United States, checks are used everywhere. New Zealand stopped accepting checks. Like banks don't, literally, you can't use a check in our country.
Same in Finland, right? They don't have checkbooks.
Yeah, it's like not a thing. There's and we don't expect that messages are going to be sent. I was going to say Telegram or something. Like things change, and the tools will get good enough that the boring work of like literally touching the keyboard, getting the program written will be done. The hard part of the system design, the hard part of like developing the product, in finding how the components work, and that you'll be driving that, but you will be driving these AI agents to essentially create or co-create some sort of artifact, and that will be a difficult shift for many people. But I think that overall, it'll be like artisanal software development where people will. It's just like having like handmade shoes feels very very old fashioned and very. I think I'm forgetting a word, but some people still like to have shoes made by hand, and lots of people would love to pay if they could. And in Japan, they still have handmade shoes, but in lots of places, but most people's shoes are made in factories and they're mass produced. And so I think most software will be, in some sense, mass produced.
Well, and I think maybe the way I think about it is we're moving one level of abstraction up. So it's no longer about, oh, how do I write this function? It's more about, I'm writing this object. I'm creating this object which knows how to interact with other objects. And then now we're saying, okay, don't even worry about the object, right? Class, don't worry about that. Now move on to, let's have modules that you're working on. Your problem-solving techniques are now coming into the module because the rest of the stuff we can go manage. And we can do it with guardrails in place, with verification in place.
The future that you're describing here, I think it's very easy to, there's a bootstrapping problem where if you start with a program, you need to kind of handwrite the properties that you wish to kind of guarantee, but it's just a kind of a fascinating idea. So then the question that becomes like, what is important about the Rust standard library as part of this overall process?
That's a great question.
The next thing to do.
Yeah, so there's three parts to it. One, the Rust standard library, contrary to popular belief, does have bugs in it which have been exposed in the past. Yes.
Yeah, we don't talk about these things.
Yeah.
It turns out it's just software, right?
So when you want to build a house, where do you start? You start with the foundation, and our foundation is the core in the standard library. And but when we make our tools actually do this for the core, the foundation, automatically, we can start making it work for everything else above it. And that's the number one reason, right?
So is part of the reason why that magic happens is once the tools are good enough to do it in the standard library, which is in some sense the most impactful library that Rust programmers have access to, then everywhere else should be at least no more difficult.
Yes, that's a great insight on your part. That is one of the ideas here, right? That the second point is the Rust standard library will challenge our tools. It will make us push the boundary, and that's fantastic, right?
I suppose that the fact that a lot of Rust programmers use the no standard attribute, such that essentially they turn off the standard library, is slightly orthogonal to this, because if I'm just on an embedded device, I could still use the verification tools. They still exist. And but essentially, this is a big, ambitious, difficult project. And attempting to use the program of work as a way to kind of recruit or essentially kind of gather a community of researchers to, or at least this is kind of I'm trying to figure out at what point did you think, you know what we should do? We should turn this into like an X Prize, like an awards. We should essentially.
I can tell you exactly when I thought that.
Okay.
It's when I realized the amount of unsafe code in the Rust standard library, and okay, one team cannot actually do this. I need a lot more support. And then, I believe the Rust community is an amazing community. It has been a fascinating community for me, at least. And I realized, well, I think that people would like to contribute because of 3 reasons. Number one, this benefits everyone, right? It benefits people who are building on top of Rust, creating their applications, their scenarios. It benefits people who are developing Rust. It benefits academia, students, researchers, industry. It's a win-win-win-win. And I thought, well, okay, but if I just go post a message saying, "Hey, let's go verify the Rust library," well, that's probably going to get drowned in the plethora and the sea of all the messages that are being posted. So the effort was born out of, let's make it more organized and let's jumpstart this, because I think there's a lot of people who are motivated out there who want to do something like this. And this gives them a great cause.
Yeah, the Rust community is not, by the Rust community, the messages, where the message presumably you would have sent if you were to sort of say, "Hey, by the way, I'm looking for," would have been like the Zulip channel, like the main one, presumably.
Sure.
I find myself lost in there all the time. So I can imagine that, yeah, it's very highly likely that your message would have been like either ignored, or you would have generated such a heated discussion that it would have been like, yeah.
I've seen a few of those recently.
Okay. Yeah, right. There is actually an effort outside of AWS that I noticed that you posted about. So I saw a YouTube video from CMU students about verifying the standard library. And your name is attached there somehow. So what's your relationship with the university, with the academic project? And presumably there's some wider context that I think would be really nice to hear about.
Yeah. Oh, I mean, you are up to date, obviously. So CMU has an initiative, an innovators initiative, where they do what's called a practicum project. And these are students who end up spending a semester selecting what projects they want to work on from a proposed set of projects. Just so
I was going to interject very slightly, just in case there's any listeners that know Latin. I've always called that practicum, but practicum. Anyway,
I guess you would have to pardon my American accent.
Yeah, it's funny how we have kind of the English holds on in tiny fragments of and let's say a more learned age, although much more colonial and far.
We still spell knife with a K for some reason.
Sure, that's right. Yeah, the KN thing I don't get, like knife, knave. Anyway, sorry, I completely derailed you. And yes, so we have practicum, which probably provides an opportunity for students to work on an industry project. That's just normally how these things are structured.
There's actually a wide variety of sponsors who come there. They're from either academia or industry. And I got the opportunity to present this idea for verifying the Rust standard library. And we ended up with 4 teams 4 very wonderful teams, I might add, of 4+1 students each, 4 students, one kind of program manager person, a couple of faculty members, and they took on 4 challenges. And let me tell you, not all of these students had any formal verification background. Some of them did not have any Rust background. Yes, that reaction is correct.
Yeah, I'm sorry for anyone who's audio only. Yeah, I'm like sort of sitting here, kind of like slightly puzzled or startled, amazed. I can't quite tell. I don't know which adjective is correct, but that's fascinating.
And each team took on a challenge. We completed a couple of challenges. The other 2 are almost finished, and students happen to be engaged even after the work is done. They have created blog posts, videos. They learned how to write Connie harnesses. They learned about Rust semantics. They pushed Connie to a new level. They were filing issues against Connie saying this doesn't work, and was absolutely inspirational to see these students take this idea and actually make it a reality. And, in my head, I thought, wow, this is the birth of a new generation of computer scientists. This is what inspired me at the end.
That's also, there are like multiple levels in which I'm amazed. The first of all, like being able to recruit 4 teams of multiple researchers, multiple, that is like that isn't like an acknowledgement of essentially the gravity or of this effort, and the way that it's perceived, and the importance of Rust. Rust is I think I've been saying this for like about a year. Rust is no longer a new language. Like Rust is not novel anymore in the sense of it's not considered unsafe. Sorry, wrong term. It's not considered kind of I don't think that there will be companies that look at Rust.
It's not a risky bet anymore.
Right. That's in the
yeah,
totally. And the same thing is happening on that side, where people know that if they were to work on this, and like solve one of these challenges, that it would have a very large impact all around the world. The other level was that, these students were relatively new either to formal verification, Rust, or both, still were able to make really strong forward progress, which means that the tools themselves, such as Kani and its ability to have custom properties and harnesses, is learnable. And that's very, very positive. And then the continuing engagement and being able to create content about exploration and blog posts and so forth is a very nice finishing touch, because it means that people have been sufficiently engaged to share, which means that the whole process was fulfilling. I mean, I don't want to gush too much about this effort, but no, it's very ambitious, and I am extremely excited that someone has decided to use their position and like their expertise in the networks to drive this. And so a thank you to you, Rahul.
Oh, thank you, Tim. I have a lot of people to thank. The Rust Foundation has been amazing during this process. Amazon itself has actually put money forward, and my leadership has been very supportive. People like you who understand. My team has just done so much work. I mean, we started the year with 0 verified functions, and we ended the year with 255 or a few more now verified functions, basically 1 a day, if you will. That's really cool. And next year, we want to increase the order of magnitude. We want to get into the thousands. and we want to get this into the mainline. The contracts, Rust is going to have contracts soon, and we've been a part of those discussions. It is a great thing to have contracts at the end of the day. It is a great thing to have formal verification actually come into this light, because I do believe those are the only guardrails AI has eventually.
Yeah, look, I mean, you can't ask the AI to just write a test that will, like, it would be nice to make sure that the thing is doing what it says that it's doing, and that it's essentially not spiraling out into mayhem. And yes, the Rust compiler, once it compiles, it runs, and you have some degree of assurance that you at least have a working program. But it would be nice to go that next extra step to say that you have a correct program. Amazing. And thank you.
Not only nice, but required, in my opinion.
Yeah, but see, this is the whole frame of reference in which I'm currently operating in. That at the moment, we don't have the idea that it's possible to formally verify kind of baked into the process. And so it's seen by, at least, you can tell that my own preconceptions are kind of like pushing against the idea that this could become part of every day. In fact, it will become central to it, because it will be the foundation that the rest of the program sits on, especially if this future comes true where the computer is doing a lot of the writing of the software. And so thank you very much for sharing with everybody the story of verifying the Rust standard library, as well as something which was very unexpected to me, this idea of essentially creating this secure foundation for a new paradigm of software development. And in 20 years, we might have another conversation and find out whether or not it happened, or like what it actually looks like. So I wish you all the best.
Thank you very much. And I hope it's sooner than 20 years.
Yeah. Right. Okay. People can take their bet. You've been listening to Compose, a podcast for software developers interested in the Rust programming language. My name is Tim McNamara, also known as timClicks, and you can find further resources at timclicks.dev. At timclicks.dev, you'll find tutorials, videos, and articles, all geared around helping you to get better at the Rust programming language to build a better planet. If you've enjoyed this episode, then here's a suggestion. Try to apply formal verification to one of your projects today. Check the show notes for resources. Check the show notes for links to resources for you to get started. Take care, have fun. I'll see you on the next episode.